Find the minimum and the maximum value of 2x plus y, where x and y are the lengths in this figure, always not drawn to scale, and 0 is less than or equal to x, less than or equal to 18. Even though we are given only one figure, one picture, we assume that we can choose any length x up to 18. But if we use the longer x, then we will have the shorter y. Our job is to determine which length x and y we should use to find the minimum and the maximum value of this quantity 2x plus y. We first need to rewrite this function in terms of x or y only. But what is the relationship between x and y? If this horizontal length is 18 and the length of the first segment is x, what remains is 18 minus x. To find the relationship between y and x, we observe that there is an invisible or imaginary right triangle that can be formed with the hypotenuse y. The horizontal leg is 18 minus x and the vertical leg is 9. Y squared is therefore 9 squared plus 18 minus x squared. So y is 9 squared plus 18 minus x squared, the whole quantity, the square root. It remains to find the minimum and the maximum of the function f of x equal to x plus the square root of 81 plus 18 minus x squared on the closed interval 0, 18. This is a continuous function on a closed interval. The extreme value theorems guarantee that there will be an absolute minimum and an absolute maximum if we check the critical numbers and the endpoints. The endpoints are 0 and 18, so we will need to find the derivative to find the critical numbers. The derivative f prime of x is 2 plus 1 over 2 the square root of 81 plus 18 minus x, the quantity squared, times the derivative of the inside the radical, which is the derivative of 81 is 0 plus 2 times 18 minus x to the 1 power times negative 1. Simplifying this, we have 2 plus negative 2 times 18 minus x over 2 the square root of 81 plus 18 minus x squared, and the 2 canceled out. We then set this derivative equal to 0 and solve for x. We move the negative term to the right hand side, which is 18 minus x positive on the right hand side over the square root of 81 plus 18 minus x squared. We then square both sides of the equation to get 4 equals 18 minus x, the quantity squared, over 81 plus 18 minus x squared, where the square root of the square root canceled out. We then cross multiply to get 4 times 81 plus 18 minus x squared equals 18 minus x squared. 4 times 81 is 324 plus 4 times 18 minus x squared is 4 of 18 minus x squared. The right hand side is 18 minus x, the quantity squared still. We then move 4 of 18 minus x squared to the right hand side, so 324 equals 1 of 18 minus x squared minus 4 of 18 minus x squared is negative 3 of 18 minus x squared. And so 18 minus x squared equals 324 over negative 3, which is a negative number, and the right hand side is positive, so there will be no such x. In this case, there will be no critical numbers, so the minimum and the maximum occurs at the endpoints only. We could not find any critical number because solving this equation would lead us to no solution because the squared cannot be negative. It remains for us to check the endpoints only. When x equals 0, f of 0 is 2 times 0 plus the square root of 81 plus 18 minus 0 squared, which is the square root of 81 plus 18, or the square root of 99. When x equals 18, which is another endpoint, f of 18 is 2 times 18 plus the square root of 81 plus 18 minus 18 squared. But 18 minus 18 is 0, so we have 36 plus the square root of 81. This is 36 plus 9, or 45. The square root of 99 is the square root of 9 times 11, or 3 root 11. With both of these numbers, we see that 45 is the maximum and 3 root 11 is the minimum value. So the x and y that will give us the minimum and the maximum occurs at the endpoints only, and the minimum value is 3 root 11, and it occurs at the endpoint x equals 0. The maximum value is 45, and it occurs at x equals 18, which is also the endpoint.